which is the linear regression. In linear regression, the basic idea of how we go about fitting a line I gave you, but how do we do it actually in mathematically and then also programmatically, that I wanted to discuss. So, Aman, can you just take a look at it? In half lecture I will need this. Okay, so the idea was if we have a function like, suppose we have some points, a cloud of points, and we want to fit a line. So this is your x and this is your, say, y, okay? This is your x and this is your y. And suppose you want to fit a line through this, which will have equation like what? H of theta x equal to, what is the equation of line?
Theta 1.
हाँ? ये क्या line का equation है? Theta 0 plus theta 1 x, okay? So then for this fitting, okay, we will have a, this is called as what? This is called as which function? Which function? Hypothesis function. This is called as the hypothesis function. Okay. Then we have the error function. Error function क्या है? Error function is the overall, overall sum or square sum का average. Average of the square sum of the distances of all the points from this line. ठीक है? So that was j of theta. I used to write it as j of theta. So which is 1 by m. M is what? Total number of points. Total number of points इधर जितना भी है 1, 2, 3, 4, 5, 6, 7, 8. In that there is no problem. Problem is here. इसको थोड़ा सा ऊपर नीचे करो. Okay, 1 by m summation I equal to 1 to m. Then बताइए difference of the hypothesis function from the individual lines. So y h of theta x I minus y I का whole square. Okay, so this is your j of theta, or we can also write it as, this is a function of theta 0 and theta 1. Okay, or I can write it as a j of capital theta in some sense. ठीक है? So this function will look like, so this is actually equal to 1 by m summation I will, because this is h of theta x, no? So I can write this as theta 0 plus theta 1 x I minus y I का square. ठीक है? This is the same as that equation. Okay? Now my aim is to minimize this function, okay? And this function looks like, this function is a 3-dimensional function because there is a theta 0 on this side, theta 1 on this side, and a 3-dimensional function. This is a 3-dimensional function lying in the space of theta 0, theta 1, and this is your j of theta 0, theta 1. Okay? So our aim is to minimize and find where exactly, for example, this point I have to find to a particular theta 0 and a corresponding theta 1. Okay, I have to find which are these 2 points. Okay, so for that we will randomly initialize theta 0 and theta 1 to some value, which will land up, say will land up here. Okay, some random initialization of theta 0, theta 1. We don't know where exactly it lies on the valley. Then we'll start moving. We'll try to move towards the valley from there, roll off from there. Okay, how do we roll off, or how do we roll off mathematically? That's what this lecture will be about. Okay, so if you have a function suppose let's take a 2-dimensional case. Okay, this is a case where I took the function as theta 0, theta 1 x. Okay, if the function just has a single parameter, okay, which is j of theta 0, j of theta equal to 1 by m summation I equal to 1 to m theta 1 x minus y. Okay, where I have taken my hypothesis. Is my hypothesis function क्या है? Theta 1x. Okay, theta 1x. That means the if it is the point cloud, then the line will be something like this. It cannot have a intercept on the y-axis. It is just passing always through the. So this is a simple function. Say, इसका जो for this one, the error function which you will get, which is this. This is the hypothesis function h of theta x. Okay, this is your error function. Okay. Now error function will look like for this is something like this. For a two-dimensional case, this is your theta 1 j of theta. This is your theta 1, this is your j of theta. For a case where hypothesis function is like this. If the hypothesis function is like this, then it becomes a three-dimensional case because you have theta 0 on one side, theta 1 on the other. Okay, and each point on this error function corresponds to, if you go back to the hypothesis function, it corresponds to a particular. Every point on this corresponds to a particular line on the hypothesis function. A different hypothesis function. Okay, and the value on this graph, there are two graphs. One graph is this one, other graph is this one. Okay, every point here corresponds to a particular line. Okay, and every means this value theta 1 corresponds to a particular line with a particular theta 1 value, and the j of theta value corresponds to the average error of which this line would make, the average error which this line would make, okay, with respect to all the points in that. Okay? Any doubts? कोई पूछता ही नहीं कुछ? Are you guys understanding? Don't hesitate to ask questions, okay? ठीक है? So, if I have to roll down this hill, first thing which I will do is I will calculate the derivative, okay? I will calculate the derivative of this point, at this point for this function. ठीक है? I will calculate the derivative of this function at this point, ठीक है? Which is given by dou j theta by dou theta 1. Okay, so this is that the derivative of that function at this point. Okay, with respect to theta 1. Okay. Now what we will do is, अगर हम इस point से बहुत ज़्यादा दूर खड़े हैं, if we are standing very far away from the valley point, we want to rush towards the valley point, okay, as fast as possible. So near this point, what is the derivative of this function? 0. On this point, the derivative of this function is 0. As you go up, the derivative is more and more steeper. So that means derivative is higher as you move far away from this point. So if you have randomly chosen a point, where the point is exactly in the beginning, you have randomly chosen one. Okay. This point you calculated the derivative is something which is dou j theta by dou theta 1. Okay. Why I am using dou instead of dj by theta by theta 1, you will see that will become clear here, okay? Because we want to fix one axis and derivative with respect to other axis, and fix other axis and derivative with respect to, so there is a partial derivative. Although here partial derivative is the full derivative, okay? So here, what I'll do is, I will jump from, if I am standing at theta 1, let me. So initially I will, randomly initialize a theta 1, okay? Randomly initialize a theta 1. For that theta 1, calculate dou j theta by dou theta 1, okay? Okay? Next, theta 1 equal to, computer language में इस तरह लिखते हैं, means the next step of theta 1 equal to the current position of theta 1 minus alpha dou j theta by dou theta 1. ठीक है? So in this step, what we are doing is, if I am standing at theta 1, thing is I want to jump from this theta 1 to a new theta 1. Okay, so this is my, say, theta 1 new. Okay, so what will be the theta 1 new? Theta 1 new is given by theta 1 current, which is this position, minus function at this point, multiplied by a current, which we call as the learning rate. This is called as the learning rate. Okay? Alpha is called as the learning rate. Okay? So what will happen is, here suppose theta is say 100. Dou j theta by dou theta 1 100. What will happen? Suppose your alpha is 0.1. Alpha is 0.1. Then your total jump will be, say you are standing here at say theta 1 equal to 200. Derivative is 100. Okay. So this is 200 minus alpha is 0.1 multiplied by derivative at this point, which is 100. So you will jump how many points? 200 minus 10, which is 190. Okay. So you will basically jump 10 points here and come here. Okay. Again, in the next step, you do this in a loop. Loop this. Keep doing it. Okay. Once you are here, again calculate what is the derivative here. Okay. And then multiply alpha and subtract it from the current new theta. Okay. That way what will happen is that you will first jump along. But here what will happen, the derivative here is larger or in the second point is larger? First point is larger, so from this, then from this point to this point will be smaller. From this point to this point even smaller. Okay. And will keep merging. Here the derivative is 0. So you will not move to the other side. Understanding? So you will basically roll from here. You will roll faster if you are away from the valley, and you will roll slower when you approach the valley. Okay. Those who are from electrical engineering, they can understand in terms of control systems. You know, control system there are overdamped systems, underdamped systems. So here it is a underdamped system. Dheere se aake it will merge to this point. Okay. Then there are overdamped systems where if your alpha, which is your learning rate, is very high. If alpha is very high, what will happen? Suppose alpha equal to say 10 hai. Okay. 10 nahi, suppose alpha is equal to 15 hai. Okay. So what will happen? 15 multiplied by 100, which is 150. Okay. So you will reach what is it? 50. Suppose this point is say standing at 100. So you will to the other side. समझ रहे ना, ये 50 है. अगर अल्फा लर्निंग रेट बहुत हाई हो गया, even with the same initial conditions, you will jump first from here to here, then from here you will jump here, then here, then here, then you will kind of bounce around and come to the point. But this is faster. You know, you will be able to reach very fast to the point. With only 3-4 steps you might be able to reach. But if alpha is too high, what can happen is you jump from here to here. Learning rate is even, here the slope is even higher than this, absolute slope. Okay. So what will happen from here to here, and then jump out of the valley, out of that bowl. Okay? So your learning rate should not be so high that you jump out of the bowl. Okay? It should be optimally better you keep it, you know, reasonably low so that you come down without much oscillations. But if speed of a problem, or you want faster speed of convergence, then you can try, which will make you converge faster. But many times, you know, those who are not aware of machine learning paradigms, they, you know, many conferences or, you know, projects people do, and machine learning you don't want to apply because it is slow. Actually, machine learning is not slow. Machine learning is probably faster than general. Okay, what is slow is training. Okay, training means initially जो मॉडल को ट्रेन करने के लिए ये थीटा 0 थीटा 1 निकालना है. ये निकालने के लिए आपको इतना ये तो have a 1000 parameter model. You might have to go around and find that exact point. That training might take you say 1 day on a GPU or something like that. Okay, but once you have found these values, theta 0 theta 1 that values, उसके बाद तो ये एक single function है, you know. Executing it is much faster than executing any, if then else loops and all. So initial training can be expensive, but once the faster than any conventional algorithm. Okay? So where were we? Okay, so this is your learning rate alpha. Now what happens is, this is a function which this is called as a convex function, okay? Convex functions are those functions which just have a single value, okay? Those functions just have a single value. So what happens is, if you have a function which have multiple values, and suppose you initialize the theta 0 here, you initialize theta 1 here, you will land up here. Valley, because here the gradient will become 0. After that you cannot go up. As per this, that 0, you will not be able to move. So this way you will land here. If your random initialization, initial random initialization of theta 1, random initialize here, you will land up here. Okay? But it so happens that for linear regression cost function, okay, the error function is a bow-shaped convex function, okay? So bow-shaped convex function means you can initialize anywhere. You know there is only one value. You will anyways land up there, okay? Now this is, now let me write it a little bit. After this is your first step, this is your second step. From that theta 1, calculate loop of theta 1 equal to theta 1 minus alpha dou j theta by dou theta 1. Okay? Suppose you have not only theta 1, but you have also have another parameter theta 0. Here, ये तो मैंने जो example solve किया वो किसके लिए किया? This function के, okay, which just has a single parameter theta 1x. Okay, suppose we want to do it for this function, okay, or sorry, this function. It has two parameters, theta 1, theta 0 and theta 1x. Okay, so then what you want to do is loop theta 0 minus alpha del j theta by dou j theta 0. You do for every theta. ठीक है? So suppose आप एक पहाड़ पे खड़े हैं ना, you are standing on a hill somewhere. You want to go to the valley of the hill. You have to take two decisions. जो पहाड़ी साइड से आते हैं उनको पता हो hills कैसे, you know. You have to take two decisions, like in x direction कितना दूर move करना है, and in y direction कितना move करना है, okay? Because there are two dimensions in which you are moving. So that way you will determine. Although पहाड़ी का जो लॉजिक है उल्टा है इससे. पहाड़ी में कहना अगर ज़्यादा स्टीप है हम धीरे चलते हैं, इसमें ज़्यादा स्टीप तो तेज चलते हैं और कम स्टीप है तो धीरे चलते हैं, ठीक है? सो इसमें वी नीड टू देन टेक these two decisions. एक पॉइंट पे खड़े हैं, वहाँ पे कैलकुलेट करेंगे कितना नीचे राइट साइड जाना है, एक्स एक्सिस में कितना दूर जाना है थीटा 1 में, थीटा 0 में कितना जाना है, एक बार वहीं पे डिसाइड किया. ऐसा नहीं कि यहाँ पे मूव कर गए थीटा 0 कैलकुलेट करके फिर यहाँ पे कैलकुलेट किया थीटा 1 कितना मूव करना है, ऐसा नहीं. ठीक है? At every point you calculate all the derivatives. ठीक है? Here there are two, because two are some things which you can imagine. After two you cannot imagine, because उसके बाद वो 4 dimensional space 5 dimensional space में चला जाएगा. ठीक है? But mathematically it can be done. Mathematically you just have to do theta 0 equal to theta 0 minus alpha del theta 0 by del theta 1, theta 0, theta 1, theta 2, theta 3, same. Keep repeating. Okay? Yes. It may not always be, because here you don't have a function. What you have is a cloud of points. You have a cloud of points. You have to find, there is no fixed one single function which hits all of them perfectly. Okay? What you're trying to estimate is what value of theta will lead to, that optimal curve. Not like, I have given you that the function is y is equal to x square. So differentiation is 2x. It's not that way, because you have table of numbers. Understand? No? So it's not a simple function you can differentiate. So that's why these all things are required. So now coming to here, okay, so this is our j theta, theta 1. J with respect to theta 0. Can you do it? इसको करो. Dou j theta 0, theta 1 divided by dou, with respect to theta 0. तो कैसे करेंगे इसको? 1 by m is a constant. Okay, so that 1 by m comes out. ठीक है? So derivative of a summation is summation of the derivatives, right? Derivative can go inside the sum. So we move the derivative inside the sum. Okay? So first one will be, before that, because it will be a what is a series of derivatives. What is called? Chain rule. ठीक है? Because यहाँ पे square है ना, तो इसको पहले पूरा का पूरा u लेना है. u square का square, तो पहले क्या हो जाएगा? 2 summation, ठीक है, I equal to 1 to m, 2 multiplied by this full thing, which is theta 0 plus theta 1x minus y. I means you with respect to where the variable is. Okay? Because this is the error function. Error function में ये देखिए variable कौन से axis में? Theta 0, theta 1. But the same thing, look from the hypothesis function perspective, theta 0, theta 1 becomes constant. And x1, x2, x3 becomes variable. ठीक है? So that's the difference in perspective. We got this. This is your u. Okay? After that, what will happen? You go inside and derivative with respect to theta 0. क्या होगा इसका derivative with theta 0? बताइए. इसका आएगा 1, इसका 0, because this thing is constant with respect to theta 0, because we are doing partial derivative. This one is also constant with theta 0. Okay? So it's simply multiplied by 1. ठीक है? So your dou j theta by dou theta 0 becomes this function. So what we'll do is, this function will become theta 0 equal to theta 0 minus alpha, this function. ठीक है? You basically put this one in place of this. ठीक है? Next, dou j theta by dou theta 1. ठीक है? I am using this and this notation alternatively. ठीक है? Is equal to क्या आएगा? PO. ठीक है? So it will become 1 by m summation I equal to, ये 2 बाहर ले आ सकते हैं यहाँ पे. ठीक है ना? You can get this 2 out. 2 by m summation I equal to 1 to m. What will happen? Theta 0 plus theta 1 xi minus yi स्क्वायर तो चला गया. उसके बाद आप अंदर जाएंगे, विथ रेस्पेक्ट टू थीटा 1 करेंगे. ये पहला क्या हुआ? 0. नेक्स्ट वन xi. ठीक है? सो यू विल हैव xi मल्टीप्लाइड हियर. ठीक है? देन दिस वन इज 0. ठीक है? सो देखिए आपको सिर्फ एक एक्स्ट्रा मल्टीप्लाई हो रहा है. ठीक है? एंड देन दिस वन गोज हियर. ठीक है? एनी डाउट पूछ लो. ठीक है? बाद में फिर समझ में ना आए. ओके? Now this is a simple model where I use theta 0, theta 1 x. Suppose I would have a model which has theta 0 plus theta 1 x1 plus theta 2 x2 plus plus theta 3 x3 minus ये I है सब ऊपर. ठीक है? So suppose this is my model. Model का ये, suppose this is the model h of theta. ठीक है? इसमें 4 मतलब टेबल में पहले क्या था? एक x था और एक y था. अभी टेबल में आ गया x1, x2, x3 आउटपुट्स y. ठीक है? तो उसमें ये मॉडल लगे थीटा 0 प्लस थीटा 1 x1 प्लस थीटा 2 x2 प्लस थीटा 3 x3. अब इसको डेरिवेटिव करें तो क्या डिफरेंस आएगा? डौ जे थीटा बाई डौ थीटा 0, मतलब इसका एरर फंक्शन हो जाएगा क्या? दिस थिंग विल बी रिप्लेस्ड बाय दिस. ठीक है? सो देन डौ जे थीटा बाई डौ थीटा 0 विल रिमेन सेम, बट ये वाला हो जाएगा क्या? थीटा 0 प्लस थीटा 1 x1 प्लस थीटा 2 x2 प्लस थीटा 3 x3. ठीक है? और विथ रेस्पेक्ट टू थीटा 0 तो 1 रहेगा. ठीक है? नेक्स्ट ये वाला तो वही होगा, बट यहां पे हो जाएगा x1, ये हो जाएगा x1 प्लस थीटा 2 x2 प्लस थीटा 3 x3, ठीक है। नेक्स्ट डो जे थीटा बाई डो थीटा 2, क्या हो जाएगा डिफरेंस, सिर्फ x2 मल्टीप्लाई x1 की जगह x2, ठीक है। सिमिलरली जितने वेरिएबल्स बढ़ाते चलो, जस्ट able to move along any dimensional curve, ठीक है। कितने डायमेंशन का एरर फंक्शन हो, you will be able to minimize it by using this kind of gradient descent, ठीक है। So there are a couple of two other things which I want to another thing is sometimes you want that multi-dimensional हो गया, gradient descent for multiple variables. तो x1 x2 बताया, suppose you want to do along x1, suppose you have this data given x1 x2 and y, ठीक है। ऐसा डेटा दिया हुआ है आपको, जैसे कार का नंबर ऑफ डिस्प्लेसमेंट, इंजन डिस्प्लेसमेंट, एंड सपोज दिस इज माइलेज, ठीक है। ये 3 दिया हुआ है। Now you think that it is not a simple linear relationship. You don't think that this is y equal to theta 0 plus theta 1 x1 plus theta 2 x2. You don't think that this is such a simple relationship. You think that the relationship should be something like theta 0 plus theta 1 x1 plus theta 2 x2 plus theta 3 x1 square plus theta 4 x2 square plus theta 5 x1 x2, ठीक है। So this is the relationship which you think you would better fit them, okay. So how will you use this same concept to apply this model? What you'll do is x1 x2 जो दिया हुआ है, you create another row here, x1 square, x1 x2 square, x1 x2, ठीक है। x1 x2 से x1 square derive कर लो, x2 square derive कर लो, x1 x2 derive कर लो, okay. And then use these as x1, x4, x5. Use these as simple different variables, ठीक है। For x1 you will have theta 1 x1, theta 2 x2, theta 3 x3, theta 4 x4, theta 5 x5, ठीक है। And calculate theta 1, theta 2, theta 3, theta 4, theta 5, ठीक है। And then you will be able to optimize it, ठीक है। Then you can fit that to these variables and you will be able to get the optimal point. Another one which is important, before doing any of this, what you want to do is feature scaling, which is an important step, okay. You can write this, speed up the entire, we can speed up and ensure better convergence. We can speed up and ensure better convergence by scaling each of our input variables roughly in the same range, ठीक है, typically between -1 and 1, ठीक है। So what will happen is, suppose your number of cylinders in a car can vary from say 1 to 6, ठीक है, 1 to 6 or 2 to 6 or something, while the weight of the car can vary from say 700 kilos, say 2000, 3000 kilos, okay. So you can see one variable is varying along from 700 to 2000 or 3000. Variable is varying between 1, 2, 3, 4, 5, okay. So what happens is that if you try to directly optimize it, the curve might come out something like this. This error curve might come out something like this, you know, very thin on one side but very wide on the other side. It's like a bowl which is very thin on one side, very wide on the other side. So then what happens is, you nudging on one side moves the variable like hell on one side, एक side. Convergence पे problem आता है. So what we'll do is, suppose this is your x1, x2 and this is y. These are certain values, we'll scale all these values between -1 and 1 approximately, not essentially exactly -1 and 1, but approximately same range. So what we do for this is, x1 equal to x1 minus x1 का mean divided by standard deviation of x1, ठीक है. दिस इज कॉल्ड एज नॉर्मलाइजेशन ऑफ द वेरिएबल्स। इसमें हम मीन सबट्रैक्ट कर रहे हैं, मीन्स अगर वो जैसे कि